Now you guys do remember that we did have systems that did not have one solution. Either there's no solution or many solutions. And we're able to do that graphically, but how in the world are we going to be able to do that through substitution method? What in the world would that look like? So I have an example that's going to be one or the other of these. So let's see what we discover here. I have a system, two equations. Equations really aren't reduced. They kind of started us out with some work to do. So let's do some work first. So let's rewrite both equations. I'll write the system again. So it's y plus 1 equals a 5x plus a 5. Subtract 1 from both sides. So y equals 5x plus 4. All right, so that's the first line. I'm going to recreate my system. So the first line is equivalent to 5x plus 4. The second equation is still 5x minus 1. All right, I have a system here, and we can use substitution. Both of these are solved for y or set equal to y. So if 5x plus 4 equals y, y equals y equals 5x minus 1. Therefore, 5x plus 4 equals 5x minus 1. So solve that for x. Subtract 5x from both sides. And I get 4 equals a negative 1. Ugh. I guess, well, maybe we set it equal to 0. That will help. Let's add 1 to both sides. 5 equals 0. All right, that's not much more helpful either. 4 equals negative 1 or 5 equals 0. That's a false statement. That cannot happen. And because I got a false statement while I was working through my substitution, that tells me that no matter how hard I try, there's not going to be a solution. I happen to stumble across a system of parallel lines. And you guys can see that by observation that the slopes are the same. So that would tell me that I'm expecting parallel lines with no solution. But if I didn't catch that, and I solved it or tried to solve the substitution, I got to something that does not make sense or that's untrue. And because of that, there is no solution to this system. Let's look at another system that we'll come across. This system has many solutions or infinitely many solutions. How do I know that? Well, let's work through this and see what happens. We'll want to solve it by substitution, and notice the first line is already solved for y. Yay us. So it's 4x. So I'm going to take that y and substitute it into the second line for y. So this new line or this new equation is identical to the second one in the system, other than I took my value of y and dropped it in there and substituted. Let's solve this to work this out. 2 times 3 is a 6. Minus a 4x equals a 6. 4x minus 4x, collect like terms. I get 6 equals 6. I can subtract 6 from both sides if I wanted to, and I get 0 equals 0. So it looks like what happens, regardless what happens after I get to 6 equals 6, I'm going to get some statement that's obviously true. 6 equals 6. 0 equals 0. Or whatever else I may get. When I notice that, that tells me that whatever solution works for one works for the other. It's a true statement here. Therefore, this system has infinitely many solutions.